Welcome to Ask and Learn.
This problem from your textbook is very, very important because this touches on really the foundation of chemistry, which is how atoms and molecules bind to one another. And we know how they bind, and they bind through the transfer or sharing of electrons. And that's what this problem is about, drawing Lewis structures to see how these electrons interact between different atoms in a molecule. So the first molecule that we need to draw is a oxygen atom bound to a carbon bound to a sulfur. So we put our least electronegative atom in the center of our compound. So we put carbon in the center. We'll have two double bonds, one to oxygen and one to sulfur. And then we have to consider the octet rule. And the octet rule says that the octet, or the orbitals surrounding these electrons, have to be full. So carbon can only have 4 bonds around it, so that's met, we're good. Oxygen, though, we're missing 4 electrons after that double bond, so we'll add 2 lone pairs. These are called lone pairs if you don't know that yet, and these are just electrons. It's how chemists denote them. And again, with sulfur, we're missing 4 electrons, so we'll put those lone pairs on the sulfur atom. And now the question becomes, what is the formal charge? Now we use formal charge to say that what is the charge of these atoms in this compound? Are they neutral? Do they have a +1 charge, a -1 charge? And so here's a little trick to find formal charge. Formal charge is equivalent to the valence number of electrons minus bonds plus dots. Okay, so let's go over this equation. Let's do oxygen. Or let's do carbon because we know how to deal with these double bonds. Okay, so the valence number of electrons is 4 minus the bonds, 4, plus the dots, 0. So we see that we have 4 minus 4, which is 0, so carbon is neutral. So that's what this means. The dots are just the lone pairs, the bonds are the number of bonds around that atom, the valence number is the outermost electrons of that atom. So we're going to be using this process for all the other molecules in this problem. And after you do a few, you'll get the hang of it. So for part B, we have to do SOCl2. So we put our the least electronegative atom in the center. That's our sulfur. It'll be bound to an oxygen and 2 chlorine. And then we have to add our lone pairs. So each atom besides the sulfur atom will have 3 lone pairs. And now we assign formal charge, the same thing that we did before. Valence number of electrons minus bonds plus dots. So we can do oxygen just so I can show you how we get the hang of this. The valence number of electrons on oxygen is 6. We'll subtract the bonds plus the dots. So bonds is 1 plus the dots, which is 6. So we have 6 minus 7, which is -1. So we'll see a negative charge in that oxygen atom. So that's how you go about this. And so let's move on to the next compound. Now we have bromine bound to 3 oxygen atoms. Now the tricky part about this one is that we're told that the entire molecule has a -1 charge. So we'll just have to keep track of that. So we put bromine in the center. It'll be bound to 3 oxygen atoms. Again, you can calculate the formal charge the way we did before. And we'll find that bromine has a +2 charge, and each oxygen atom has a -1 charge. And then we'll keep this entire molecule with a -1 charge. And now for the last one, we have HClO2. So we have we have a hydrogen bound to an oxygen that's bound to a chlorine that's bound to an oxygen. Again, use the equation valence number minus bonds plus dots. So then you'll find we have lone pairs on all of the atoms besides the hydrogen. Hydrogen, you'll see, will never have a lone pair. And we'll calculate the formal charge. We'll get -1 on oxygen and a +1 on the chlorine. So I hope that this helped you understand how we can draw the Lewis structures of various compounds and how we can put lone pairs on the atoms, and then calculate formal charge. And this is so important because this is the foundation of all of chemistry, seeing how these things bond together, which will tell us how they react.